Greetings. Today I'm home alone, no one's around, so what better opportunity to do something completely irresponsible. Now this, if you, by the way, if you, by looking at the screen right now, if you figured out what I'm about to do, fantastic. If you haven't, well, you'll have to wait until I explain everything. So this will be a video that's inspired by a video from Mr.Carlson's lab, and by all means I'm not mocking him. That guy has got vast amount of knowledge and his videos are great. He's got a great channel, so by all means I do recommend you subscribe to him. Yeah, he's recently posted a video, and the video was titled "Are Your Caps Wrong Way Round?" Or something along those lines. So I immediately thought of something, yeah, the video was different. Of course, he was talking about a serious subject. So he was talking about old gear and where you change your foil caps. It is, even though they're not really polarized, it's really important to keep the outer foil on a certain side, depending on what's in your circuit, and that basically shields the whole capacitor and reduces the hum and noise and whatnot in old vintage stuff. And by all means, his video was completely serious. But what it reminded me of, or actually the title of the video, is reminded me of what you'd used to do when you've got you know how to, and you're in, you know, electronics high school and whatnot, and you play pranks on your colleagues. So yeah, this video will be about are your electrolytic caps wrong way round? And I've got a selection here of caps. So I've got a little tiny one, 10 volt, 33 microfarad, nameless brand, no branded. Another one slightly thicker, 25 volt, 330 microfarad. Again, it's not obvious what brand is it. I've got a Lelon cap, so it's a good name brand, 22 microfarad, 50 volts. Another Lelon cap, this one is 220 microfarad, 25 volts. Now I've got 4 Rubicons. This is a 16 volt, 47 microfarad. And again, Rubicon is a great brand. 6.3 volt, 100 microfarad, so low voltage one. I was trying to pick a good selection of different flavors. This is 6.3, 470 microfarad. Different selection of voltages and capacitance. 35 microfarad, 330. Sorry, 35 volt, 330 microfarad. All those 4 are Rubicons. And here is Capson, Capson. 470 microfarad, 16 volt, and the big boy, 100 microfarad, 400 volt. So what I've got here is a piece of pine wood, and I've put 2 holes into it, put a piece of copper wire into each hole, so I can solder and position each cap in sequence. So let me put those away a little bit without losing the track of what's what. And I think the first one will be the little 10 volt, 33 microfarad nameless cap. So let's get him soldered in. So where's my solder? There it is. And of course it's important to observe polarities, so it is incorrect on this instance. Okay, let me center him on the camera. Okay, we are behind the blast shield, and yeah, this is probably as close as I can get. So power supply on. Let me get the voltage down. Oops, I'm moving everything. There we go. So output on, and we are, that's a 10 volt cap connected backwards, so we are at 1 volt output, not much doing, current not flowing, 2 volts, three, 4, 5, 6. Oh, the suspense. 8. Not much happening yet. 9. There is 30 milliamps going through this. 10 volts, so we are at the capacitor's nominal voltage backwards. So it's drawing 30 milliamps, just about. So nothing's happening just yet, really. Oh, stop drawing the current. Let's increase. Okay, 14 volts, 70 milliamps. Whoa! I got scared. That was a nice pop. Okay, at least I know what to expect later on. Okay. And what happened with this one, it has vented from the bottom. It's got its guts out at the bottom of the cap. I need to make sure not to jump on the next one. Anyways, let's get him off. So what this poor guy did is basically vented out at the very bottom, the rubber gasket let go and it popped with a slight little pop. Anyways, now let's get to the bigger one. 25 volt, 330 microfarad, again nameless nameless cap. It's got some markings, but it might mean something, but I'm not too sure what they are. Okay, blast shield on, and the blast shield is just a piece of acrylic box that I had. I knew it will come handy one day. Anyways, power supply on, and messages coming through. Output on, and we are at, oh, that was quick. So this guy vented straight away through the top, and it made me a mess on the blast shield. And yeah, so this ruptured at the top pretty much instantly, and I jumped again, which is not good. Maybe because it was slightly unexpectedly quick. So conclusion, perhaps it's really hot. The big ones pop quicker. Okay, next one up, the Lilon cap, 22 microfarad, 50 volt. So let's get him mounted. Okay, I guess that's where it needs to be. Now this one hasn't got the venting slot, so I suspect this will get busted from the bottom. So anyways, I've remembered to put the voltage down on this occasion. What was it, 50 volt this one? Okay, so, and I'm committing myself not to jump. So again we're going 1 volt, 2 volts, 3 volts, 4 volts, no current flowing, 5 volts, 6, 7, 8, 9, 10, 30 milliamps, 50, 70, okay, I'll leave it at that, 80, 10 volts, 80 milliamps, let's see. He's probably getting really warm right now. Okay, 60 milliamps, let's go up, 10 volts, 13, 14, 15. It's showing 250 milliamps and dropping, so 250, 100 milliamps at 15 volts. Let's go up a little bit. 20 volts, 300 milliamps, 400, 500. Poof! Yay! Now this is why I can't do that when everyone's around. But yeah, this one has basically disintegrated very beautifully. So we've got the isolation paper and the foil that goes around. I'm not sure where the actual case is. Oh, there it is. It ejected itself from the case. So yeah, that's an interesting failure mode. So yeah, what's left is the electrodes. All the paper has really nicely exploded and expanded itself, and it's covered in electrolyte. And here is the foil. Yeah, that was inside. So yeah, that was a nice one. I think that was the most effective one so far. But I didn't jump, which is good. Anyways, let's move on to the bigger one. So let's take the voltage down again, because it may explode prematurely. This is again Lilon, 25 volts, 220 microfarad. Now I think this one's gonna be loud. So Again, let's just clean the last chamber. There we go. Lilon, 220 microfarad, 25 volts. Backwards. Power on. And 2 volts. 3 volts. 4 volts. 5 volts. 6. No current draw yet, or not significant. 7 volts. 8. 9. 70 milliamps, 80, 90. Okay, let's leave it. The current draw is rising, so I suspect that's gonna be enough to get him pop. If we do it slowly, you might be able to see how it will expand on the top. Okay, 300 milliamps, no, 200, sorry, and it's dropping now. $150 milliamps. And the current is dropping, so maybe let's give him a little bit more. So 15 volts, 16. Oh, there we go. It popped. Now I'm doing this because if you're watching this, you might be new to electronics and you will hear something that a cap will... oh, that's really hot. The cap may explode if connected incorrectly and you do it irresponsibly, and yeah, you could do it out of curiosity, and I'm doing this so you don't have to. This one vented controllably, not like the other one that disintegrated itself completely. What was that? That was the... oh, that was Lilon as well, actually. Yeah, this one. So you can see that the slots on the top do make a difference. It felt really controllably, it just popped and vented out. So that's that was a good way to fail. And yeah, this is the big capscot. This is gonna be really loud, I think, but we'll leave that for last. So now we're gonna move to Rubicons. So this is 6.3, 100 microfarad. So let's get him in. Now this one hasn't got the ventilation slots cut on there, so I suspect he will eject himself out of the seat completely and leave his guts hanging around all over the place. Let's get the voltage back down before we switch it back on. Power on, output on, and 3 volts, 3.5 volts, no current draw. 5 volts, 6.5, 20 milliamps, 30, 40, 7 volts, 50 milliamps, 60, dropping again, 40, 30, 20, 7 volt and no current, so let's up it up. 10 volts, 130 milliamps, 140, 150, 130. I've noticed that when I increase the voltage, the current increases, but then it drops down significantly. It's down to 80 milliamps at 10 volts. Everything must be boiling inside, because the reason why those explode is the electrolyte boiling away, turning into steam, creating pressure, and that's what makes those pop. Okay, 10 volts, not much doing. 50 milliamps. 15 volts. Ooh, 400 milliamps. And dropping. 360. Oh, now it's gonna go. There we go. And again, it failed somewhat controllably. Again, vented out from the bottom. The rubber gasket went out. It's really hot. But yeah, it didn't eject like the other one. Yeah, the rubber gasket let go and just popped out. Sorry, focus. There we go. So, I guess controllable failure. Moving on, we've got now the Rubicon 16 volt 47 microfarad. Again, without the slots on the top. So let's put this on. And again, back the voltage down, output on, and increase the voltage. Let's give it 5 volts. It's drawing 80 milliamps and it's dropping down. Forty milliamps at 5 volts, so it's putting some energy to it. So let's get this up a little bit. Make this quicker. 10 volts. Ooh, 600 milliamps. That's gonna go. Maybe not. The current dropped to 50 milliamps only, so let's up it again. Okay, that was 15 volts. And this one has also come out of its seat, but it's still in one piece, so it didn't went like a projectile. Really hot. So you can see again, this one ejected the full rubber gasket out of the bottom. So this is the sealing point, and they make this sorry, there we go. So they make this purposely the weakest point, so the whole rubber thing just popped out because of the pressure, and everything's still in kind of one piece. So again, a controllable failure mode of a cap Rubicon. So it made a pop but stayed in one piece, no projectiles. Okay, let's get a bigger one. This one is 6.3 volt 470 microfarad, and it's got the K rupture slot. Come on, get the idea. So this one's a little bit beefier than the other ones. It's just beefier for size wise. Okay, and let's back the volts down. Power supply on. That's 6.3 volt, 470 microfarad Rubicon. Output on, and let's give him, let's see when the current starts flowing. 3 volts, 4 volts, 5 volts, 6 volts, 6.5, 100 milliamps. And dropping 70. So let's up it to 7.5, 250 milliamps to 300 milliamps. $200 is dropping again. I think what's happening inside, the electrolyte is boiling away, and it's reducing it's not conducting anymore basically. 100 milliamps at 7.5 volts, so let's go up. 8.7 volts, 200 milliamps. $11 volts, 1.2 amps. That's gonna go. And sorry, my camera stopped recording right in the middle. So yeah, this one failed really controllably. You could see just the beginning of it, and that's all that happened. There wasn't any bang on this occasion. It just simply vented really gently after drawing 1.2 amps from my power supply. It just simply the slot let go it at the weakest point, and the whole thing just vented. Really controllable failure. And this is what you want, by the way. So if your stuff goes wrong, so you either misconnect something when you're designing, or it might be that something else fails on the board, and it will put just mispolarized voltage somewhere onto the board, and your cap gets reverse polarity. This is what you want. So you want it to fail reasonably and controllably. So it should release some smoke. You know something's gone wrong. Maybe fuse will get blown, and that's it. You don't want projectiles flying from your project all over the place. Because very often when you're working on a project, you've got stuff that's uncovered, and if this launches itself across the room, it might hit you in the eye or whatever. It's dangerous. So yeah, this one failed really nicely. We've got 3 left. We've got that's Capson 470 16 volts, a big Rubicon with 330 microfarad 35 volts, and 100 microfarad 400 volt Capson. So this is the big guy at the very end. So let's move on to the next one. Time for which one? Not this one. Yes, this one. So Rubicon 35 volt 330 microfarad. So let's get him soldered in. Of course in reverse polarity. This one has also got the K-type slots on the top. So let's get the voltage down. Shield on. Output on. And let's see. So 2 volts, 3 volts, nothing happening yet. 4 volts, 5, 6, 7, 8, 8, 9, 20 milliamps, 30, 40 at 9 volts, 50, 60, 70, 80, 90, 100 milliamps, 120, so it's growing, 140, 150, 180, 200 milliamps at 9 volts. 260, 280, 300. Okay, now it started drastically dropping down, so let's increase the voltage. 10 volts. 13. Oh, I can see it's swelling a little bit. Bang. Okay, so yet again, very controlled manner. It burst along the line over here. Really hot. But yeah, it fell in a controllable way. So this is good. The slots did their job, and yeah, it vented out quite rapidly actually, but no, but nothing wrong with that, as long as it didn't explode into pieces. I mean, the main thing about this is so you don't have any shrapnel lying around. So I've just wiped off the electrolyte from the acrylic. So the last two, we've got caps on and 470 microfarad 16 volts. Let's get them soldered in. This one has got the cross type ventilation slots, cutouts. There we go. Okay, so output on, and let's go. That's a 16 volt cap, so let's go 3 volts, 4, 5, 6, 7, 8, 9, 14. Whoa! I've got my current limiting kicked in. Ooh, this one is boiling off. Oof. Stinks. Sorry, I just touched the camera over there. But yeah, this one didn't make a bang. At one point it was drawing over 3 amps, and my current limiting kicked in on the power supply, but it vented very gently. Ooh, really hot. Really gently. So again, that's not a bad failure. You can't even tell. It's slightly bulged, but you can't even tell where the hole is. Where did it rupture? But anyways, it's really warm. Now this one. This is a big one, and I'm not sure if I'm gonna be able to get this one to pop, because it's a 400 volt cap, but certainly I will attempt. Again, it's a Capson brand. Okay, let's get the shield on. So this is the big one. Yeah, so this one might be violent. So yeah, let's do it. I'm slightly concerned with this one, but I guess it's behind the shield. So anyways, output on. 2 volts, 3, 4, 5, 6, 7, 8, 9, 10, 12. Still no significant current draw. 15, 16, 20 volts, and not much doing. $30 volts, and I've got 20 milliamps. I'm maxing out my power supply right now. I'm getting 31 volts and 40 milliamps. Okay, I think this is not gonna go very well, so let's switch this off. And what I'm going to do is I'm going to engage dual power supply, and I just need to bridge positive and negative of the 2 channels, so I'll get up to 60 volts. Output on, so that's 40 volts, 44 actually. So let me up the other side. We've got 31 and 16, drawing 100 milliamps. I'm just gonna hold this with my hand actually. And maybe put the safety glasses on. Okay, 150 milliamps at 47 volts. Let's go up a little bit. Got 50 volts, 180 milliamps. $200 milliamps at 50 volts. Why not? Full whack. I've got 60 volts and about an amp right now. go, bang. Whew. Oh, this stinks. Whew. Oops. This vented again entirely controllably. I was getting really scared at one point. Boy, this one really stinks. It's really hot. So at one point it was drawing like 3 amps at 60 volts. That's a lot. That's 180 watts was being put into this. So no wonder everything boiled off and vented. But yeah, so as you can see in this video, when you've got slots on the cap, it actually makes a difference. They do what they're designed to do. If you're looking for special effects out of the caps, use the little ones, because they will make quite more of a pop than the big ones, because they usually don't have a venting slot. And usually what happens, they will pop the bottom cap and just fly off. Just be mindful of them flying around, so no one gets hurt. But yeah, there you go. That's what happens when you get your electrolytic caps backwards. Okay, bonus content. This one here is brandless, 6.3 volts, 100 microfarad. Now, all of the previous ones, I have been slowly increasing the voltage. Now, if the failure mode is quite more spectacular when the voltage gets applied instantly. So I've got a pre-diode roughly about 15 volts. Let's double check. 18 volts. Let's put it up to 20. Okay, I've got 20 volts on the output. Oops. And I'm going to apply switch on the output right now, and this I suspect this will be quite quick and violent, because when it gets a huge amount of voltage straight away, it fails quite more dramatically, as I said. So without further ado, 3, 2, 1, output on. There we go. That was more effective. And the case hit the plastic blast shield with such an impact that it bent. So it was quite violent, and it's literally an explosion, because all the paper that's used as a insulator in the cap, it literally, well, not insulator, it is just the paper that's soaked with electrolytic, one electrode. It's literally pulverized into further like material all over the place. It's literally becomes fluff. So yeah, it's quite messy. Be aware if you're gonna be responsible. But anyways, that is this one. That is all for this one. I meant thank you for watching again, and take care.